All right, so today we're going to be diving deep into asynchronous JavaScript. We've got a ton of articles and research ready to unpack, and you know what that means. We're going for those aha moments, especially for those of you who already know basics. So a quick recap, asynchronous code, it's all about letting your web app multitask like a pro, right? It's the magic behind loading data, handling those user interactions, and you know all those things that keep your users happy and your app running smoothly. Imagine trying to fetch a user's profile data from an API while also simultaneously like trying to update the UI. Without async, everything would just like grind to a halt, and nobody wants that. But let's get into the nuts and bolts of how this all works. I've got an expert here with me who can break it down in a way that even your cat could understand almost.
Yeah.
What's the first thing we should tackle?
Well, let's start by, kind of distinguishing between blocking and non-blocking code. It's really at the heart of understanding asynchronous JavaScript. You see, traditional synchronous code execution is like picture a single-lane road with roadwork. One car at a time, everything else waits. This is fine for simple tasks, but in the world of web development, where you're often dealing with like multiple things happening at once, it creates a bottleneck.
Right, because while your code is stuck, like waiting for one task to finish, like fetching data from a server, the entire application is just frozen. That's not exactly a recipe for a smooth user experience.
Exactly. And that's where non-blocking code swoops in to save the day. It's like having multiple lanes of traffic. Even if one lane is slowed down, the others can keep moving. With non-blocking code, your application, it can continue running other tasks, while it waits for those long-running operations to complete in the background.
Okay, so non-blocking is the key to keeping things, zippy and responsive. But how does JavaScript actually pull this off?
Well, that's where one of the most important concepts in asynchronous JavaScript comes in. Promises. Imagine ordering a book online. You get confirmation, a promise, that the book is on its way. Now, you don't just sit by the door and stare at it, like, until the book arrives, right? You go about your day, knowing that when the book does arrive, you'll deal with it then.
Makes sense. So a promise is basically JavaScript's way of saying, hey, I'm working on this. I'll let you know when it's done, and then you can decide what to do with the result.
Exactly. And this is what allows, your code to continue executing other tasks without getting bogged down by something that might take a while. But there's more to it than just, making a promise. We need a way to actually handle what happens when that promise is fulfilled or if it, unfortunately gets rejected.
Okay, I'm seeing where you're going with this.
Mm-hmm.
So how do we deal with those outcomes? What happens, when the book arrives or if, heaven forbid, it gets lost in the mail?
This is where the .then and .catch methods come into play. They're how we tell our code what to do with the result of a promise. The .then method lets you specify what should happen when the promise is fulfilled, like displaying the fetched data on the page or processing it further.
So it's like saying, okay, once that book arrives, I'm going to curl up on the couch and dive right in.
Exactly. And the .catch method is our safety net. It handles any errors that might occur during the process. Let's say the server is down or the data is invalid. The .catch method, it lets you gracefully handle those situations, maybe display an error message or try, an alternative approach.
It's like having a backup plan in case the book delivery goes awry. So we've made a promise. We've set up our .then to handle the success scenario and our .catch to handle potential errors. But what if we have multiple promises happening at the same time? Things could get messy fast.
That's a great point, and this is where things get really interesting, because we often need to manage multiple asynchronous operations at once. Imagine fetching data from, multiple APIs, each providing a different piece of information that's needed to render a complete view. That's where tools like Promise.all, Promise.race, and Promise.all settled become incredibly valuable.
Ooh, those sound like powerful tools. Give us the rundown on how they work and when we'd choose one over the others. Let's start with Promise.all.
Okay, imagine you're building a weather app. You need to fetch the current temperature, wind speed, and humidity from 3 different APIs. Instead of making those requests one after the other, you can use Promise.all to launch them all simultaneously.
So it's all about efficiency. We're not just sitting around twiddling our thumbs while each request completes, right? We're making the most of our time by firing off all those requests in parallel.
Exactly. And Promise.all will give you back an array containing the results of all the promises in the order they were passed in. This is super handy for situations where you need all the data before you can proceed, like rendering that complete weather view with all the details.
Okay, I'm getting the hang of Promise.all. But what about Promise.race? When would we use that one?
Think of Promise.race as like setting a timer for which task finishes first. This could be useful for things like setting timeouts where you only want to wait a certain amount of time for a response, or cases where you have multiple data sources and you just want to use the first one that responds.
So it's like a race between those API calls to see who can deliver the data first. That's pretty cool. And last but not least, we have Promise.all settled. What's special about that one?
Promise.all settled is a bit different. It waits for all the promises to settle, regardless of whether they were fulfilled or rejected. And it gives you a summary of each outcome. This is particularly useful when you want to understand, like, the overall progress of multiple operations, even if some of them might have failed.
So it's about getting a complete picture of the situation, even if things didn't go perfectly according to plan. I can see how that would be valuable in debugging and like monitoring scenarios, but managing all these promises can still feel a bit complex. Is there a way to make the code itself a bit more, I don't know, elegant?
Absolutely, and that's where the dynamic duo of async and await steps onto the stage. They're designed to make writing and reading asynchronous code a much smoother experience.
Okay, I'm intrigued. Let's unpack these powerful keywords. What makes them so special?
Think of async as a way of, like, marking a function as asynchronous. It essentially tells JavaScript, hey, this function might have some asynchronous operations going on inside. And then we have await, which is used inside an async function to pause execution until a promise resolves.
So it's like saying, hold on a second, I need to wait for this promise to finish before I can move on.
Hmm.
That sounds a lot more straightforward than juggling all those than the end dot catch blocks.
Exactly. And the beauty of it is that it allows you to write asynchronous code that reads almost like synchronous code, making it way easier to understand the flow of execution.
That's a game changer. Can you give us an example of how this works in practice? I'm itching to see how these keywords actually like streamline the code.
Absolutely.
Yeah.
Let's say we're fetching user data from an API. With async await, you define an async function to handle that fetching process. Inside that function, you'd use await to pause execution until the fetch request completes. Then, once you have the data, you can proceed with, processing it.
Okay, so it's like saying, hold on, let me grab that user data first. Okay, got it. Now let's do something amazing with it.
It's like the code is telling a story step by step.
Exactly. And don't forget about error handling. With async await, we can use good old try.catch blocks to handle any errors gracefully. If something goes wrong during the fetch process, the catch block will catch the error, and you can handle it appropriately. This is all starting to make so much sense. It's like those async and await keywords are bringing a whole new level of like clarity and organization to our asynchronous code.
They really are powerful tools. They not only simplify the way we write asynchronous code, but also make it easier to read, debug, and maintain.
All right, I think we've laid a solid foundation here. We've covered the difference between blocking and non-blocking code. We've explored the magic of promises, and we've even delved into the elegance of async await. But I have a feeling this is just the tip of the iceberg when it comes to asynchronous JavaScript, right?
You're absolutely right. There's a whole world of like advanced concepts and techniques out there. In fact, next time, we'll be tackling the JavaScript event loop and concurrency, which might sound intimidating, but trust me, it's fascinating stuff.
Ooh, I can't wait to unravel the mysteries of the JavaScript event loop. It's like we're about to step behind the scenes and see how the whole asynchronous symphony is conducted. Stay tuned, folks, because things are about to get really interesting.
Welcome back. I'm excited to delve deeper into asynchronous JavaScript with you. Last time, we covered those core concepts of promises and async await. Now let's shift gears and explore the JavaScript event loop and concurrency, the mechanisms that make all this asynchronous magic possible.
Yes, it's like we're about to peek behind the curtain and see the wizard working their magic. This is the stuff that really makes JavaScript tick, right?
Absolutely. You see, JavaScript is a single-threaded language, right? That means it can only execute one task at a time. However, with help of the event loop, it can create this illusion of concurrency, making it seem like multiple tasks are happening simultaneously. It's a bit like a master juggler, keeping multiple balls in the air, even though they're only handling one at a time.
Okay, I'm intrigued. Break down this event loop concept for us. How does it manage all these asynchronous operations without, like, things getting tangled up?
Imagine the event loop as, like, a continuous cycle. It has two main components, the call stack and the callback queue. The call stack is like a stack of plates. The last one added is the first one to be dealt with. This is where your synchronous code gets executed one task at a time.
So it's like a well-organized to-do list for JavaScript. Each task gets its turn, And things happen in a nice, orderly fashion.
Exactly.
Mm.
Now, whenever an asynchronous operation is initiated, like a fetch request or a timer, it's not immediately placed on the call stack. Instead, it's placed in the callback queue, just like a waiting room for asynchronous tasks.
So it's like those tasks are politely waiting their turn, knowing they can't just jump ahead in line and disrupt the synchronous flow.
Precisely. The event loop, it constantly monitors both the call stack and the callback queue. When the call stack is empty, meaning there are no synchronous tasks being executed, it takes the first task from the callback queue and pushes it onto the call stack.
Ah, so that's how those asynchronous tasks get their chance to shine. They patiently wait their turn in the callback queue. And once the call stack is free, they get their moment on stage.
That's it. And this process continues in a loop, ensuring that asynchronous tasks are executed without blocking the main thread, which is essential for keeping that user interface responsive and preventing, those dreaded frozen screen scenarios.
Okay, I'm starting to see how the event loop is the real maestro of the asynchronous orchestra. It keeps everything flowing smoothly and ensures that no task gets left behind.
Exactly. Now, you might be wondering, if JavaScript is single-threaded,
Yeah.
how can it handle truly parallel tasks, like complex calculations or interacting with multiple devices?
That's a great question. It seems like there's a bit of a paradox here.
Well, while JavaScript itself is single-threaded, modern browsers and JavaScript environments, they provide these APIs that let us tap into multi-threading capabilities. This is where things like web workers come into play.
Ooh, web workers. Those sound powerful.
They are. Web workers allow us to create these dedicated threads that can run JavaScript code independently of the main thread. It's like having a separate team of chefs working in parallel to prepare different parts of a meal.
So we're essentially offloading the heavy lifting to these web workers,
Yeah.
freeing up the main thread to focus on keeping the UI responsive and handling user interactions. That's brilliant.
Exactly. This is essential for building, high-performance web applications that can handle complex computations and operations without sacrificing user experience.
Okay, I'm getting a real sense of the power and flexibility that the event loop and these multi-threading capabilities bring to JavaScript. But before we get too carried away, I want to circle back to something you mentioned earlier about best practices for writing asynchronous code. What are some key things developers should keep in mind to avoid common pitfalls and, create clean, maintainable code?
You're right. It's crucial to follow best practices, especially when dealing with asynchronicity. One of the most important things is to avoid those deeply nested promises, which can quickly turn into the dreaded callback hell.
Callback hell, that sounds terrifying. Like some kind of developer's nightmare.
It can be. Imagine trying to trace the flow of execution through a deeply nested chain of callbacks. It's like navigating a labyrinth. This is where Async await comes to the rescue. By using these keywords, you can flatten your code and make it much more linear and readable.
Right. It's all about keeping that code clean and organized, making it easier to understand and maintain. What else should developers watch out for?
Always handle errors in your asynchronous functions. This is crucial to prevent, unexpected issues from crashing your application. Remember, things can and will go wrong, especially when dealing with external resources like APIs.
It's like having a safety net in place, just in case something unexpected happens.
Precisely. Make sure to wrap your asynchronous code, especially the parts using await, within try.catch blocks. This ensures that any errors are caught and handled gracefully without bringing, the whole application down.
So it's like having a contingency plan in place, a way to gracefully recover from those unexpected hiccups. Got it. Any other words of wisdom for listeners who are venturing into the world of asynchronous JavaScript?
One more crucial tip, especially for those working with loops. Be cautious with using await inside loops. While it might seem tempting to, simply await each iteration, this can lead to performance bottlenecks, especially if you're dealing with a large number of items.
Oh, that's interesting. So slapping in await inside a loop might not be the best approach. What are some better ways to handle asynchronous operations within loops?
There are a few strategies. If you need to perform all operations in parallel, Promise.all is your best friend. It allows you to launch all those promises concurrently. And once they're all done, you get a neat array of results. This is super efficient and avoids unnecessary waiting.
So instead of processing each item in the loop one by one, we're essentially launching a bunch of asynchronous operations all at once, like a well-coordinated team effort.
Exactly. However, if you need to process items sequentially, but you don't want to block the entire loop. A technique called recursion can be helpful, though it might be a bit advanced for our current discussion. It essentially allows a function to call itself until a condition is met, effectively processing items asynchronously without halting the main thread.
Okay, so we've got Promise.all for parallel processing and recursion for sequential but non-blocking operations within loops. Those are powerful tools for, like, handling asynchronous tasks within loops.
They are. Remember, understanding these nuances can make a huge difference in the performance and responsiveness of your applications. It's about choosing the right tool for the job.
This has been incredibly insightful. We've gone from, like, understanding basic promises to unraveling the inner workings of the event loop and concurrency. And we've even touched upon, like, advanced techniques like web workers and recursion. I'm feeling pretty empowered to tackle more complex asynchronous challenges now.
That's great to hear. Remember, the key is to approach asynchronous programming with a clear understanding of these core concepts and to leverage, the powerful tools that JavaScript provides.
Well said. So, dear listener, as we wrap up this deep dive into the world of asynchronous JavaScript, I want to leave you with this thought. Now that you have a grasp of how to manage asynchronous tasks effectively, what possibilities does this unlock for you in the realm of web development? How can you leverage these skills to create dynamic, responsive, and engaging user experiences that truly stand out?
The resources are out there waiting for you. Blogs, documentation, online courses, you name it. Don't be afraid to dive in, experiment, and embrace that learning process.
And remember, even the most experienced developers are constantly learning and evolving. The world of web development is always changing, so stay curious, stay passionate, and never stop exploring.
Until next time, happy coding.
Welcome back to our deep dive into asynchronous JavaScript. I'm feeling pretty energized after our last segment where we explored those inner workings of the JavaScript event loop and concurrency. Those concepts, they can be a bit tricky, but understanding them, like, it opens up a whole new level of control and efficiency in our code. It's like we've unlocked the secret sauce of building, truly responsive web applications. But before we wrap up this episode, I'm curious to hear, like, what specific real-world scenarios or applications really, like, benefit from mastering asynchronous JavaScript?
That's a great question. There's so many areas where understanding asynchronicity becomes like a superpower. Let's think about like some common web development challenges. For example, imagine you're building a real-time chat application. You need to constantly like listen for new messages from the server, display them instantly, handle user input, all without blocking the entire UI. That's where asynchronous JavaScript using techniques like WebSockets and event listeners comes in.
Right, because if everything froze up every time a new message arrived or a user typed something, the whole experience would be, like, clunky and frustrating. Asynchronous code allows us to, like, keep things flowing smoothly.
Exactly. Another great example is handling file uploads. Uploading large files can take time, and you don't want to leave users staring at a progress bar that seems stuck. By leveraging asynchronous JavaScript, you can create this smooth upload experience where the user can continue interacting with the application while, the file uploads in the background.
Okay, so that's real-time communication and file uploads. What other scenarios come to mind?
Well, think about data visualization dashboards that need to display dynamic data from multiple sources. Using asynchronous JavaScript, you can fetch data from, various APIs concurrently, process it efficiently, and update those charts and graphs without causing any lag or interruptions. It's all about making the user experience seamless and engaging.
This is all making so much sense. It's like asynchronous JavaScript is the secret ingredient for creating those, buttery smooth web experiences that users have come to expect.
It really is. And the beauty is that this is just the tip of the iceberg. There's a whole world of advanced asynchronous techniques out there to explore. Think about things like reactive programming, where you create these data streams that automatically update the UI in response to changes, or concurrency patterns like promises and async await, which help manage those complex asynchronous workflows.
It's amazing to see how mastering asynchronous JavaScript unlocks a whole new level of possibilities for building, truly dynamic and interactive web applications.
I completely agree. It's like going from driving a car to piloting a spaceship. The potential for creating incredible experiences is limitless.
Well said. So, To our listeners, if you're ready to take your JavaScript skills to the next level, I encourage you to dive deeper into the world of asynchronicity. Explore those concepts we've discussed, experiment with different techniques, and challenge yourself to build applications that push the boundaries of what's possible on the web.
The resources are out there waiting for
Correct.
you. Blogs, documentation, online courses, you name it. Don't be afraid to, dive in, experiment, and embrace that learning process.
And remember, even the most experienced developers are constantly learning and evolving. The world of web development is always changing, so stay curious, stay passionate, and never stop exploring.
Until next time, happy coding.